Hi friends, we are in the next part of basic definitions of set. We have discussed definition of set, roster method, set builder method, what are the elements in the set. Now we are going to continue the other all definitions. So if you have not seen that video, that is in the description, you can watch the video, okay, so that you will be clear with the earlier basic definitions which I have discussed. Now let's go with the next definition, null set. What is null set? We also say null set as empty set or void set, but commonly we call it null set. So a set which does not contain any element is known as null set or empty set or void set. It is denoted by this pi symbol, okay. Even we say this symbol as null set, okay, or this, the brackets which are enclosed and there is no elements in the bracket. You can see there is no element, okay. You have to make a note that null set is empty. The set which does not contain any element is known as null set, okay. Next example I'm giving, the set of natural numbers less than 1. So you know where from the natural number starts. Natural number starts from 1, 2, 3, so on. So natural numbers does not have less than 1 elements, so the set is empty. This is a important point, that this and these are different, because empty set is denoted by this, that the set which does not have any element is known as null set. So but here in the set there is an element 0. Don't be confused that if 0 is there, this will be a null set. No, this is not a null set, okay. So this is null and this set which has an element 0 are different sets, okay, where 0 is an element in the set, so don't be confused and be clear with this point. Now next definition, finite sets and infinite sets. Finite sets, here finite set definition and infinite set definition. If we can count the number of elements in a set is called finite set. If we can count the number of elements, look here, 2, 4, 6, 8. How many elements are there? 4 elements. So we can count the elements. So 1, 2, 3, 4 elements are there. If we can count the elements, it is known as finite set. Otherwise it is called infinite set, okay. Next, finite set. See, example is here. Finite set, we can count the elements. How many elements are there? 1, 2, 3, 4 elements are there. Infinite set, we cannot count the elements. 1, 2, 3, 4, so on infinity. We can't count how many elements are presented in that set. So infinity, infinite set and finite set, okay. So here the next definition is cardinal numbers. Number of elements in a set is called cardinal numbers. Look here, how many elements are there in the set, finite set. I'm giving an example of a cardinal numbers of a set. So how many elements are there in finite set A? N of A is equals to how many elements? 1, 2, 3, 4. So 4. How many elements are there in infinite set? There are infinite number of elements, we cannot count. So n of B is equals to infinity. This is the symbol of infinity, okay. Then cardinal numbers, a number of elements in a set is called cardinal numbers, okay. So the next definition is subset. We denote the symbol of subset by this. This is known as subset. Like we will pronounce A is subset of B, like that. So a set A is a subset of another set B, okay. We will say A is subset of B if all the elements of A are elements of the set B. B contains in it elements, but set of set A, all the elements of set A are in set B, then we say A is subset of B. In other words, the set A is contained inside the set B. So here examples of subset. I'm giving an example of subset. So A is a set, elements are 1 2 3 4, and B is a set, elements are 1 2 3 4 5 6. So we represent it in an illustration Venn diagram. I will discuss Venn diagrams in next video. Venn diagrams, we represent a set in a diagrammatical manner so that it will be easier to understand. So here is an example of subset. I am giving an example of subset. How we represent subset. A is equals to, if a set A is 1 2 3 4, and here the another set B is 1 2 3 4 5, then you can see that 1 2 3 4 contains in B, right? But A is a smaller part of B, right? Look here, B, this is B. So B has elements of A. Each element of A is in B. So you can say B is the big set and A is a smaller part of B. Okay, B is a big set and A is a smaller part of B. Look here, A is a smaller part of B. Here one more example. How we can say that A is a subset of B. We denote subset. Look, how you will recognize A is a subset of B and how to write in this form means, first write, if A is a smaller set of B, then B must be here and open mouth must be towards the bigger set. Remember like this, so it will be easier for you to understand. Okay, look here. So B, and another example, so it will be easier for understand. A is equals to A E I O U. If a set A is A E I O U, look here, second example, A is equals to A E I and B is equals to A E I O U, then you can see A is contained in B, right? A is contained in B. Yeah, A is contained in B. But can you see that if is it possible that B is contained in A? Or is all the elements of B are contained in A, so that we can say B is a subset of A? No, na. So because O and U are not in A, so we cannot say that B is a subset of A, because all the elements of B are not in A, but all the elements of A, that is A E I, are in B, A E I, but all the elements of B, that is A E I O U, are in A. A contains only A E I, so A is a subset of B, that is A elements are in B, so A is the subset of B. All the elements of A are in set B, so A is a subset of B. Okay, I have represented this set example in Venn diagram. So this is set A and this is set B. Set A contains A E I and set B contains A E I O U. So if these both sets, you can see that the elements are greater, there are the cardinal numbers are 5 in B when compared to A. A has 3 numbers, that is A, I, E, and in B, that is A, E, I, O, U. Does A contains elements of B? No, but B contains all the elements of A. So A is said to be a subset of B, but B is not said to be a subset of A. So are you clear with the definition here. Are you clear with the definition of subset? Now, equal set. If each element in set A belongs to set B and each element in B belongs to A, then A is equals to B. Okay, if each element of set A belongs to set B, look here, the elements of A are 1, 2, 3 and elements of B are 1, 2, 3. So each element of A, each element 1 is in B, 2 is in B, 3 is in B of each element of A belongs to the elements of B, and each element of B, see, 1 is in A, 2 is in A, 3 is in A. So each element, there must be no different elements. Each element of A, how many elements are there in A? All elements should be belonging to the set B. Each element of set A must be belonging to the set B. Then we say that these both sets are equal. Okay, these both sets are equal, that is A is equals to B. Look here, if A is a subset of B, see, A belongs to B, yes, and does B belongs to A? Yes. So A is equals to B. Each element belongs to this, so we can say that A is subset of B. A is subset of B and B subset of A, then A is equals to B. So there is again an important point here, every set is a subset of itself. So we can conclude by this equal sets definition that every set is a subset of itself, such as A is subset of A and null set is subset of null set and B is subset of B. Okay, thank you.